Okay, so today I plan on looking at the characteristic equation, state diagram, and state table of a JK flip-flop, different ways of writing Verilog code for latches and flip-flops. If I don't get any other input, I'll go over questions. Okay, so I wanted to start with doing a characteristic equation, and I'm going to do the JK flip-flop, although you'll do the same thing, even if he gives you, like he says, a hypothetical flip-flop like you had on your homework problem that has a given behavior. You could do that. But we're going to just do JK, unless somebody would rather me do a different one. Okay, so the first thing that we need to know is how does the JK flip-flop work. So let's write down our table for it. Now, I could do this in two ways. I'll do an abbreviated way, and then I'll fill it in all the way, because all the way will make it easier for us to do our Carnot map. Okay, so the first way that I'm going to do it is just going to tell us what the output is in terms of Q, without specifying if Q is 0 or if Q is 1. Okay. So if J and K are both 0, then the next value of Q is whatever the previous value of Q is. If K is 1 and J is 0, this is a set, and the next value of Q will be 1, regardless of what the previous value of Q was. If J is 1 and K is 0, the next value of Q will be 0. And if J is 1 and K is 1, then you get a toggle. So that would be Q bar. So that tells us what it does. So that's easy to see. So this says, so that's set, that's reset, that's toggle, and this is stay the same, or no change. But for me, to make the characteristic equation, it's helpful to do a Carnot map, and then I would like to have not just Q and Q bar, which describe the behavior, but actually the numbers, 1 and 0 for Q. So I want to put in all the possible values for J, K, and Q. So I'm doing this. I was helping someone who's taking a math class where they're doing logic, and I'm like, oh, logic, I know all about logic. But then when they do their truth tables, they put the ones first. They don't count like in order with binary. And so when I just started writing my truth table, I started doing it like I was doing it with him. Okay, so those are our 8 different possibilities for our 3 values of J, K, and Q. And we know when J and K are both 0, it's no change. So Q star is whatever Q was before. So it's just going to have the same value that Q was before. When K is 1 and J is 0, then Q star is 1. When J is 1 and K is 0, then Q star is 0. And when they are both 1, then Q star has a toggle. And then to get our characteristic equation, we'll do a Carnot map for Q star. So I'll look in my truth table, and everywhere where I have a 1, I'll put a 1 in my Carnot map.
What does that say about toggle? Does it reset?
It says reset.
Okay.
It theoretically says reset. I don't know what it actually says. Thank you. I make mistakes, lots of them. Someone's gonna fix one for me, right?
Isn't 1-0 set at 0-1 reset?
Probably. I always forget, and so I looked at something that I just printed off of the internet to make sure that I did it right, and I probably did it wrong. So hold on, let me see. Let's see. JK01 is 01 is 0, yes. So the place I copied it off of on the internet was not the right place to copy it from.
That's why you can't cheat.
Yeah. Thank you. I don't know why, for the life of me, I cannot remember which one is which. And here, I was even careful. I even looked before I did it, and I got it. And the same place that I got it from, it had Verilog code, and I said, oh good, I'll get this Verilog code. And I looked at it, it's like, that's just wrong. You know, so it was just like, there's no way it would compile. So, you know, things on the internet are not always perfect. All right, let me,
He probably puts in the wrong check answers.
01.
ChatGPT is always off. You can never get actual answers.
Some things might
Yes.
go
Okay. So that is definitely, that is correct. All right. Okay. So now that means I need to also change my truth table. Now that one was right. Okay. So 01 is 0, and oh. And 10 is 1. Okay, so now I'm going to fill in my Carnot map everywhere where I have a 1. I'll put a 1 in my Carnot map. So JK00 and Q1, so that's right here. And JK10, I have 1s for both of those. And JK11, I have 1s for both of those. And so that would get me, yeah, and please do stop me if, yes, okay, yes.
Why would the last line be 1 if it's a toggle, isn't it Q bar?
Thank you. Yes, all right. I also have not gotten much sleep lately. 1110, yes, okay. What else? And that was it, okay. I really appreciate y'all catching me before I get to the end of this and say, why is this wrong? Okay, so I do believe that would be the best way to cover these. And so this gets me that Q star equals J Q bar or K bar Q. And that does look right. That seems to be what I remember. Okay, so that is my characteristic equation right there. So this is my characteristic equation. So your characteristic equation will be what you get from your Carnot map after you write out your truth table. And if you have to draw a circuit, this is where you would go from here, because now you've got it right here. You can, you know what you would need to have if you were going to draw your circuit. Usually with sequential circuits, you're going to use D flip-flops as your elements that you'll have that operate on the clock, because D flip-flops, their output is what their input is, and so the whole point for the D flip-flop is that you're using it for the when part of the circuit, that it only changes at the clock input. The what is obvious. The what for a D flip-flop is whatever is coming in. And so if I had to make a JK flip-flop out of D flip-flops, then I would have, actually I would not need to, yeah. No, I would just be drawing the JK flip-flop. So ignore everything that I just said. I don't know what I was talking about. Okay. All right. So next I want to do a state table and a state diagram. The state, yes.
The Carnot map form.
Thank you. What's wrong with it?
The bottom right, the 111, that should be a 0. And then the box to the left of it, that should be a 1. Because 1, 0, 1.
Yeah, but on the Carnot map, remember the rows on top don't go in order of binary. This is the 1 1 right here.
I thought it was the one that was always
No. So the reason the Carnot map is set up that way is because you need, in order for the Carnot map, you might not have paid attention since you had this in 2741, but the reason it works is that every box is different from the box immediately next to it by only one of the things. And so if I did this in order, if I did 0 1 and then 1 0, then these would be different from each other by 2, and then the whole method wouldn't work. And it's just like, well, why does the method even work? Well, you can go back and look in the book to remind yourself of that if you're really interested. But the whole method of circling these depends on the fact that these the ones that are right next to each other are different by only one variable.
So it functions the exact same way, as long as we put it the way you do it. Like everything that we learned from it in 2741.
This is how you learned it in 2741.
Oh,
It is, I promise. Yeah. So a Carnot map, it goes 0 0 0 1 1 1 1 0. Yeah. Yeah. So. Yeah. Okay.
I feel like I did.
Well, I remember learning about it sitting in Dr. Trahan's class, watching why it worked. But then you don't ever use it like that. Why it is the way it is. But it does kind of mess you up because the truth table goes in the other order. The truth table you do in order of binary, right? And so truth table, when you do a truth table, you do 0 0 0 1 1 0 1 1. Okay, so a state diagram. You have your states, whatever your states might be. And I would call my states here 1 and 0. And 1 and 0 are just what my output is. It's either 0 or 1. And then, depending on what my inputs are, that will tell me what my next state is going to be. So I'm going to put 0 over here and 1 over here. So what you do when you do a state diagram, and you'll be doing a lot more of these, is you say, what are all my possibilities? If I'm in state 0, what are my possibilities for my next state? Well, it depends on my j and my k. And for my j and my k, I have two variables, so I have 4 different outcomes. So if j and k are both 0, then, and I can write that as j bar, k bar. Or I could write it as j equals 0, k equals 0. Either way. If they're both 0, I stay where I am. And if, let's see, j is 0 and k is 1, if j is 0 and k is 1, then I also stay at 0. So that would be j equals 0, k equals 1. And then when I write it as an expression, I have j bar, k bar plus j bar, k. And we're going to simplify that in a minute. So my next possibility is that I have that j is 1 and k is 0. So that would be j, k bar, or j equals 1, k equals 0. Or if I have a toggle, that would be that they're both 1, jk, j equals 1, k equals 1. This is just going to be kind of the rough draft of my state diagram, because usually, not always, but often you can simplify these transition expressions here. So those are all of my possibilities starting with 0. I went through all 4 of my possibilities for my j and k inputs. Okay, so now if I'm in state 1, if j and k are both 0, I stay in state 1. And I'm just going to write j bar, k bar. I also stay in state 1 if j is 1 and k is 0. So that'd be plus j, k bar. Now, if j is 0 and k is 1, so that'd be j bar, k, that takes me back to 0. Or if I get a toggle, which is where they're both 1. Okay, so now let's see if we can simplify this at all. So I'm going to look at this first expression that I have on my 0, j bar, k bar plus j bar, k. If I factor a j bar out of that, I get k bar or k. What is anything or, like if I have x or not x? Okay, if I have, what is the truth value of saying x or not x?
0.
Other one. 1. So everything has to be either true or not true. So if I say this is either true or not true, I have just said a true statement. Absolutely. Now if I say this is both true and not true, then I have said a false statement. So k bar plus k, that's just 1. And what is anything, so this is j bar and 1. What is anything and 1? Itself. Yeah. So this is j bar. Okay. Now, so in my simplified one, I have j bar. Okay. Now let's look at the transition from j k bar. So I've got j k bar plus j k. Can y'all look at that? And by making a comparison to what we did on the first one, figure out what that one would be?
It's just j.
Yep. So that's just j, because if I factored out a j, I'd have j k bar plus k. That would be 1 times j. Okay, now this one, j bar, k bar plus j k bar. If I can factor out a k bar, I get j bar or j. So that would be k bar. And then
Just can't guess.
that one would just be k. And I'm just looking and seeing, I actually have that right, and I have it here for me to look at. Okay, so this is a state diagram. And there are multiple ways to do it. I could also have given my states names. I could have called it S0 and S1, or I could have called it A and B. That doesn't really matter. And also on the transitions, rather than putting J, I could put J equals 1. And sometimes I do that because sometimes I find it more helpful to do it that way. Okay, now let's do a state table. Okay, so when you do a state table, you have your present state, and you have your next state. And later on, when y'all have functions that have outputs, you'd have you'd have another column over here for your output. But right now we don't have an output. So this is present state, that's Q, and our next state is Q star. And this is just one flip-flop. Because it's one flip-flop, I only have two states, 0 and 1. If I had two flip-flops, then I would have 4 states based on the, did you get the email that had the wrong room number on it? I'm sorry. I feel bad about that. Okay, so, and now the next state depends on your inputs. So I like to write out explicitly what my inputs are. Theoretically, I could just write here J bar, K bar, J bar, K, and that, but I like to say exactly what they are. And then the next state, I'd fill that in. Make sure I get this right. 0, 1, 0, 1 is 0. 1, 0 is 1. And 1, 1 is toggle. So that is a state table. Now you also, if you were to do this, and sometimes you really do need to do this, you will have it, if you had names for your states, it would look like this. Okay, so now I'm going to do it using names for my states. So my present state is Q, and then I have my next state, Q star, and I have JK equals 0, 0, JK equals 0, 1, JK equals 1, 0, and JK equals 1, 1. And there's nothing to this other than replacing the binary numbers that I have in my first table with whatever names I give to the states.
So what's the point of doing that?
It's because as you get to more complicated things, you will have, the states will have meanings, because like maybe you're designing, you'll talk about this in class, designing a vending machine, and your states are, the person has put 50 cents in, the person has put 75 cents in, and these, you'll just have a name, so you know, it'd be 75 cents or 50 cents or something that will have more of a meaning to it than state 001 or state 101. It's just easier for us as humans a lot of times to say my states are named A, B, C, D, E than to give them 3-digit binary numbers. That's the only reason for it. Okay, so are there questions on characteristic equations, state diagrams, and state tables? Okay. And I'm going to stop this and save it. Full of mistakes that it is. But because of that, I'm just going to warn you, I don't ever go back and watch these. And so I've posted all those nice videos. I say they're nice videos. In my head, they're nice videos. But chances are when I did it, last semester, it has like the same sort of thing. I wouldn't have left anything in it that I knew was wrong. If I knew it was wrong, I would not have posted it at all. But I might make a mistake and then have to fix it later.